Hi everyone and welcome back. In this lecture, we're going to get our environment set up, and I want to introduce this more high-level overview for those of you that want to try and solve it on your own. And this may look familiar. In the last lecture, you saw this, so if you read through it, my apologies, we're just going to go through it really quickly. First things first, in this project, we're really aiming to keep it as simple as possible in the sense we don't need to import too many libraries. We're basically just going to be using NumPy. For that, we just need to import NumPy as NP. Usually the common reference for NumPy. And we also want to set up our environment. As you'll see here, and we're just going to go through this again really quickly as an overview, the first step for our Q-learning is we want to define an environment that the postman has to navigate. We need that environment set up so we can actually iterate and go through it. In this lecture, the environment is going to consist of states, actions, and rewards. States and actions are inputs for the Q-learning AI agent, while the possible actions are the AI agent's outputs. Our states, we can think about and look at this image as our representation. The states in our environment are all the possible locations within the city. We can call this example city. Some of these locations are the city boundaries, which will be our black squares, while other locations are aisles that the postman can use to travel through the city. Those are going to be the white squares. The green square indicates the item, packaging, and shipping area. The black and green squares are what we're going to call terminal states. So overall, our goal, or our AI agent's goal, we want to use the shortest path. We want our agent to learn the shortest path between the item packaging area, which are green, and all the other locations in the city where the postman is allowed to travel. In the above image, we have 121 possible states or locations within the city. These states are arranged in a grid, 11 by 11. Each location can hence be identified by its row and column index. So what would be our first step? And this is really, I want you guys to start thinking about how you can define it. We need to define our environment. This is a good example of our image and how we're going to approach it. So how would you model that? Remember, we're using NumPy. So we need to define these boundaries, and we can define a 3D NumPy array to hold our current Q values for each state and action pair. As we see, our representation, and for those of you who are not familiar with it, or maybe this is new, or you want to just have a refresher, the AI A through Z handbook from this course is extremely helpful. Highly recommended. So what do we have to do here? We can actually, let me just expand this really quickly for us so we can view it a little easier. Let me just add some code cells. We're going to define our 3D NumPy array. How would you go about this? So we have some options, but the most really straightforward and simple option, let's call it environment rows, and let's set it to 11. It's an 11 by 11. And then we can also do environment underscore columns, and we can also set this to 11. Lastly, we can set our Q values since we need to add our NumPy with the environment rows, environment columns. And we can set this as Q values equal to NumPy.zeros. And we need to use our environment rows, environment columns. And we have our 3D NumPy array, our 3D environment representation set with our environment. Awesome. Now, and we're going to leave it off here, but I want you guys to start thinking about how to solve this since you already have your environment set up. The next thing that you're going to want to do as a hint is set up your actions. Your agent needs to be able to move through the environment. So how would you represent that? How would you write that in for this problem? Let's leave it off here. In the next video, we're going to revisit those actions. Awesome. I'll see you guys in the next video.